Today we're talking about, section 7374, and what we are specifically talking about triangle similarity. So today we're going to prove that triangles are similar using AA, which of course stands for angle, angle, SSS, side, 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 SAS, side, angle, side, and then we're going to use triangle similarity to solve some problems. Saved you a bunch of writing. This is already typed up. AA postulate. If I'm going to use the AA postulate, all I need to know is that two angles of one triangle are congruent to two angles of another triangle. Then I can say that the triangles are similar. Side, angle, side. If two sides of one triangle are proportional to two sides of another triangle and the corresponding included angles are congruent, then the triangles are similar. Side, side, side. If the sides of two triangles are in proportion, then the triangles are similar. So it asks us to do some problems here. Again, this is important here. The examples down below, I would pause this video and try doing them on your own. Just think about what it might be. You don't have to write it down, so you don't have to erase it if you're wrong, but just think about what it might be. But this is important. This is how the answer should be. So if triangle ABC and DEF are similar by the AA postulate, then that's what you would write. Triangle ABC similar to triangle DEF by AA postulate. This is what the answer should look like. Hopefully you paused it. See if I can get this to show up. Let's just talk about this first one. It gives you some pictures, gives you some triangles. I've marked mine up. Again, these are vertical angles. We should know that these two are congruent to each other. So that's got an arc and that's got an arc. These lines are parallel. How do I know that? Because this set of arrows on those lines, which means I have two sets of alternate interior angles. So I have angle A congruent to angle B, angle C congruent to angle D. So all three of my angles are congruent. By AA, I only need two, so that's sufficient. So triangle EAC is similar to triangle EBD by the AA postulate. Pause, try to do that second one, slide over. Alright, so this one I just messed up my sides. So if 4 over 7.2, I'm not sure that it is yet, I'm questioning, if 4 over 7.2 is congruent to 6 over 10.8, and if that's also congruent to 9 over 16.2, then all my sides are proportional. And if I do that in my calculator, I do see that it is. They are proportional. So by side, 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 triangle JKL and triangle MNP are similar. This one, not enough information to say anything about similarity. I know this side and I know that side, I know that angle and I know that angle, and that's all I know. That's not going to be enough information for us to make any kind of similarity statement. Here, so again, hopefully we see that we have vertical angles. So these angles, let me put it more in the middle. So these angles are congruent. If I take 3 over 6, that is 1/2. If I take 4 over 8, that is also 1/2. So these two sides are proportional. These two sides are proportional, and I have side, angle, side. Triangle DHG similar to triangle FHE by the side, angle, side theorem. That was basically one whole chapter we just zipped through. Now we're going to get through another one. And of course we'll do a bunch of practice problems in class. If a line parallel to a side of a triangle, so here's my line. At line XY is parallel to side AC of the triangle. So if a line parallel to a side of a triangle intersects the two other sides, there's my intersection right there at X and Y, then it divides those two sides proportionally. So XY is parallel to AC. So BX, this length right here, over XA, BX over XA has to be equal to this length, BY over YC. So whenever I have a parallel line and triangle that's hitting two sides, I can take this length over that length, and that must be equal to this length over this length. practice problem. I shouldn't have uncovered that yet. If you haven't already seen it, just think about what it's asking you to do. It's asking you to find EG, which is that length right there. Arrow, arrow shows that GH is parallel to ED, so I can then use the triangle proportionality theorem. So I can take this piece, 6, over this piece, which I don't know, we can call that x, has to be equal to this length over this length, and that's all we're going to do. So I have 6, this length, over x. I'm letting this be x because I don't know what it is. That must be equal to this length over that length. Again, that's why we've been spending time solving proportions. Cross multiply and you get x is equal to 9. Again, a lot more practice in class. Triangle angle bisector theorem. See if I can get it to show. There we go. An angle bisector of a triangle, there's my angle bisector, divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Blah, 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 blah. It's a mouthful, might not be clear. It's two different ways to think about it. The notes decided to go this route. So angle bisector. So angle BAC is being bisected by segment AY. So they're taking this piece, this BY, and they're putting it over YC. BY over YC gives me 15 over 9. Basically, you're taking the opposite piece over the other opposite piece, 15 over 9. Then they're taking the two adjacent sides, AB, this piece over this piece, 40 over 24. If you divide those two out, you'll see that they are proportional. I like to do it a different way. I think it's an easier way to set up, and I have it written down below. So here's our practice problem. And again, we'll do a bunch more in class. If you're not getting it right now, don't worry about it. So similar picture, except it's turned. They turned it up. There we go. So I like to do mine like this. I like to put the adjacent side over its basically its corresponding opposite side. Set that equal to its adjacent side over its corresponding opposite side. So if I do that, I'm going to take x plus 3. This is the side that's adjacent to my angle that's being bisected. X plus 3. And we're going to put that over the opposite side from that same angle. X plus 3 over x. And that must be equal to this adjacent side over its basically matching opposite side. So I can take x plus 3 over x must be equal to 10 divided by 6. That is my proportion. X plus 3 over x, this one over this one, equals 10 over 6. This one over this one. Cross multiply, you'll get x is equal to 4.5. And notice up here they wanted to find LP and LM. But once we know what x is, LP is just 4.5 and LM is 7.5. Bunch of practice on these in class.